Hello everyone and welcome back again to another lesson in this OpenGL series, and we're gonna explore lights in this lesson. Since I already supported you with the light class or the light library DLL library, which I already have uploaded to you, please use the latest version which you have, and um, and it's actually quite easy to use. Let me just close this starting page now. There are some stuff which I would like to discuss with you before I actually get into working with lighting here. So first of all, I import just lights. So let me go here. You just enter references, import lights. All right, and your utils has to be enabled lighting. Okay, so be careful. You have the lighting should be enabled. Other than that, you will not actually get lighting working at all. Well, you're gonna actually end up with a lot of errors and so on. So please make sure about that. After you set your attributes and everything in your OpenGL, let me collapse that. You set the initializers. Now, initializing the light, you have to, in order to use the light class, in OpenGL, you have 8 lights, all right? And these 8 lights, this is the only ones which you have. This is how your video card cannot handle actually more than those 8 lights, okay? Um, what you have to do before using any lights, you have to use it like so. Light dot initialize lights. Okay, so light dot initialize lights. Right now you initialize all the 8 lights, but you are not using any one of them. Okay, this is a must to have line. You should actually do this before using lighting. Okay, now next you have to create a new object of a light, and you define what is the light type. Okay, and once you define what is the light type, you have a light. So you have a spotlight, you have a directional light, you have a point light. A directional light is for simulating, for example, something like sun. A directional light, if, for example, the light is traveling in a certain direction. This is a directional light. A spotlight is more like you know this kind of a circular light, which you usually see for example, in theaters. Let me show you an example here real quick. Let me bring it here. So this is actually a spotlight. So you have a light, it has a certain angle, which is the cut off, all right? And well, it has a direction and it has a position, okay? Direction by default, if you don't set the light direction, it's gonna be pointing from up down, okay? If you would like to set the direction, you have just to say set. So you have to say light 1 dot set spot direction. Here you go, and then you pass the X, Y, and Z, of course. So right now I know actually that the light is gonna be pointing from upwards down. So I just set the position. I just pushed it up from the origin upwards, like 5 units up, and that's it. And the cutoff angle is defining how much or how large the circle is going to be, or how large the cone is going to be. So you have it something like but remember, when you say the cutoff is going to be 20, the full angle is going to be 40 degrees. So make sure that you are putting, for example, make sure that you have to understand that the angle is calculated from the center. So imagine that there's a vector from the center, okay, and there's another vector from here. So your angle is measured from the center to the edge. So these are the 20 degrees which are defining. Once you say 20 degrees, it's going to be immediately reflected here also another 20 degrees. In total, it's going to be 40. If you would like to simulate something like a ball that shines light, you just give a cut of 180 degrees, and it's going to be it's going to shine everywhere. All right. So this is a very important thing you have to know. Let me close this. So I defined actually the diffuse. So it's going to be 1.5, 1.5, 1.5. So it's going to be a bright white light, and alpha I set it to 1. Set the position to that point and set the cutoff at that certain angle, or set that certain degree. And what I've done here, I just rendered a small a small sphere here. Let me put this not 30, but let's say 20 or 15. Let me put this here to 15. A quadric sphere here. I just used a solid GLU a sphere here. I just created by my hand. And you have to understand there is something which is called light models, and how light is actually behaving once and material models, and how materials are behaving once the light hits the materials. Now, specularity defines how the object specularity is actually defining how the light is reflecting in a certain way of the object. So if you don't understand exactly what does that mean, hold on a second, let me bring you another small example here from my second screen. Here's just a second. There you go. Now watch this. This what happens when the light hits a surface, a diffuse surface, without any specularity. So it is exactly the same thing when you see a kind of a dim plastic surface, or like a material or like a cloth, which doesn't have a specular kind of an effect to it. Let me show you what does mean specularity in a real image. Let me see here in Google. I will Google it in a second. Specular reflection. Well, reflection could happen. Let me see here. Or let it be specularity. It's gonna make it more sense. Now here you go. Watch this. This point is your specularity. This defines how the light is once it's reflecting off a surface. It defines this circle. Usually you see it on metallic objects, or in some objects which metallic objects. It could be, for example, like a very smooth surfaces, you can say so, or shiny, or kind of reflective surfaces a bit. So you tend to get this specular highlight. All right, this is quite important. For example, right now here's a comparison of specularity against roughness. So the more the rough the surface is, the more you get not so much kind of concentrated specularity. Now with a let me see here. With a higher degree of roughness, you get, with a less degree of roughness, you see it's more like a metallic object, tends to be metallic. And with a higher specularity, you get a higher kind of highlight here, or kind of shininess here. Now watch this. A diffuse light, once the light is hitting the object, you're gonna see the normal object. But once you define a specularity parameter to it, you're gonna get the light, you're gonna get the color of the object, but plus you're gonna get actually that kind of this small highlight. If you are talking about lasers, their specularity is gonna be 100%, because they're gonna reflect off the same way. Like it's a good way to represent how lasers are going to reflect. Just hits the mirror and goes out. This is how a laser will behave, just a specularity of 100%. Emission, it defines how the object is going to emit light. So it gives the object, the material of the object is going to just emit light, and that's it. But in OpenGL or documentations, the emissivity, or the emission of an object, so if the material is producing light, it will not affect the light beside. It will not light up the scene, all right? So it will not light up objects beside it. It will just emit light, and that's it. It's like phosphoric lamp or phosphoric object. When you just an object that shines in the dark, it doesn't light up the scene. It's like the same phosphor kind of handles in your watch. It doesn't light up the whole scene, but it just shines in the dark. So this is a very important thing you have to understand about emission. Shininess. When you define shininess, how shiny the object you're gonna be, it's just a simple vector you are passing here. One more note here I would like to tell before I move actually and execute this demo about emission. Right now the emissivity is set to 1. I would like to set it to 0.5 or 0 actually. Let me put it as 0 here, and I'll leave this alpha to 1. When you look to a light, or when you look to the sun, you usually see it as a bright object, just as a white object. It is the same time is emitting light, and at the same time it's completely white. Now when you are actually setting something like a lamp, or something like so, or something like a sun, if you make the sun as an object, when the sun has to have a material of emissivity 100%, so it's going to be 1111 all of the way, and it has also to emit light. So you're going to put actually the light object, or the light you're gonna position the light at the position of the sun object. Okay, and the same thing goes for any simple lamp. Whenever your object is gonna emit light, please put the emissivity or the emission to 100% and put the light in there. So you're gonna have much more realistic effect of a light is shooting off. Let me go here and let me get here and just put a lamp. Let's hope that I have an image of a lamp here. It is already turned on. I'll watch. Yeah, I'm trying to get something in here. Unfortunately, I will not get something. I just want to say something real quick here. Let me put here sun. So watch this. That's quite good example. You see, it's completely bright white circle or completely bright white sphere. Okay, so when you put a sphere like so, put the emissivity of this sphere is 100%. And at the same time, there's a light object is sitting here and shooting off light in all directions or in a certain direction or whatever. So please make sure this, for example, when a lamp in your room is turned on, you're gonna have the same exact effect. When, of course, if the lamp is working with a 100% intensity, okay, if it's 100% intensity, you're gonna end up with something like a bright white or yellow, bright white or bright center certain object. It doesn't matter. So this is a quite important thing you have to know. Okay, so when you pass the materials, so material FV. By the way, the OBJ loader handling all this. Okay, so you don't want to you don't need actually to do this by your hands. So you can define everything in Maya, as for the specularity, emission, and shininess, and then inside the OBJ loader can understand all these variables. It already can handle it. So material FV, so it's going to be applied to the front faces only for now, and I'm right now addressing the emission, and I just passed the emission array. And it's array because material F stands for float and V stands for vector. So it needs actually a vector to get for a vector of data, for example, or to understand or to produce the emission and specular and shininess. Right now, shininess I pass it the vector and it has only a single value. It's by default it's like 15.000, so it's gonna be just a default. So I just pass only a single guy here. And here a small debug message. I left you already with some global tracks, number of available light, you can actually access it, and the light and the list of lights, which if you want to play with the list of lights, if you are making something like a very real-time engine and you for example managing more than 16 lights, so probably would like to turn on and off some certain lights. So this is more than 8 lights, excuse me, so probably would like to turn off one and turn on another one, and so on and so forth. So you have the list of lights, available lights. It's gonna be very handful for you if you're gonna use it in making real-time engines. Alright, so let me collapse those guys. So you have already an idea. Generally you don't need to set this. I set this only just to see the effects of the light, how our object is gonna behave under certain variables. But generally, when you're gonna import your objects from OBJ files, you're gonna just need to initialize lights and set the lights, set the light types, set the diffuse, set the position, set the cutoff if you, for example, have a spotlight or so, and that's it. And later on, inside here, rendering scene, you just simply pass the object which you want to render. So debug, start without debugging, give it a second, and I have 7 lights available to use. 1 is used since I already created one single object of light. And watch this. I put the specular highlight to be, hold on, yeah, the specularity is set to 3, so a bloody red. So at the end you get a point red color, and the shininess is the white, kind of white halo which you see over here. And watch this. You see how the light actually goes, how the object, right now it's a sphere, you see how the light fades off and gives you this shade. Now, what happens if I try to put the emission to like 0.5? Let me copy this over. So Control C, Control V that, and Control F5. So I get 7 lights used again. And watch this. Even though the light doesn't hit that part, but it's actually emitting light. Now, what if I put this to 1, 1, 1? 1 and another one, Control F5, 7 lights to use, and watch this. There's no specularity. Right now, it emits light so much that's already, like, how can I say, it just reflects everything, so you don't see any kind of specularity anymore. It just reflects all the lights. It just emits light already, so there are no, logically, there is no any kind of there are no any kind of light reflections here are gonna happen. So this is how actually to use the lighting class. Alright, I advise you for more information, if you would like to know more information about lights, much more advanced tweaking for the lights. Already the light class is handling all the advanced lighting. If you would like to do what you want to do, if you would like to add materials or material model or light models to the class, please feel free to. It's an open source project. But generally, if you would like to make something advanced, please refer to the OpenGL programming guide and the OpenGL Super Bible. They have tons of materials and tons of code samples of how you could actually simulate light conditions inside OpenGL. And please also make sure that your utilities class, you set attributes function has all these functions set. Alright, so thank you guys for watching. See you in the next lessons.